Welcome to the iMETOS MobiLab training. For using MobiLab in its full dimension, you need to download the MobiLab software, the MobiLab Sampler App on your smartphone, and you need to create a Fieldclimate account. The MobiLab software must be requested from our support team. Search for METOS firmware and you will reach a homepage with a collection of manuals and troubleshootings. At the end of the homepage you can find the link for the support to request the software. You'll get a mail with a zipped data. Download it, unzip the folder, and install the software on your computer. The MobiLab Sampler App is needed for creating sample IDs and also for tracking your sample taking. Search in your Android or Apple Store for the MobiLab Sampler and install it on your smartphone. The Fieldclimate account is used for the synchronization of your MobiLab Sampler App and your MobiLab software. Search for Fieldclimate and register on the Fieldclimate homepage. It's necessary to confirm the account via mail. Once the installations are done, the booting of the system can be started. This is the USB hub. It's connecting all the devices with each other. Now the battery connection must be established. The red cable belongs to the plus pole and the black one to the minus. There's also a security cap for the battery, which is fixed on its base with 4 screws. The USB hub must always be charged during the time of use with the 2-pin cable, which is connecting the USB hub to the power source. It's really important that a battery connection is done first before adding power to the hub. With this USB cable you are able to connect your USB hub with your laptop or computer. There is only one USB input that matches to the plug. If you are using a laptop, please make sure that it's fully loaded before you start using MobiLab. The peripherals are needed for the sample preparation of your soil samples. The first one is the shaker and the second one is the scale. There's only one way to connect the cables due to the different connectors. Please be careful with the scale, as this is a very sensitive device. Lift the scale only by its metal part to avoid damage on the load cell. Now the MobiLab main unit needs to be connected with the white USB cable and the power supply. The hub has 3 identical USB inputs. It doesn't matter at which one the plug is attached. Find the correct adapter for your country and plug it into the power cable. This is an overview for the setup of doing soil samples. It includes the USB hub, the shaker and the scale for doing the soil preparation. For doing just plant sap or water samples, the connection is much easier and you will not need the USB hub, the shaker or the scale for the sample preparation. This chip is responsible for the separation and detection of your nutrients. It has a small channel inside where the liquids can flow. It can be used for more than 500 measurements if it's treated well. There is a conductive grease on the electrodes. Avoid wiping it off because it protects the contact points from oxidation. After the grease is gone, the contacts may turn black within a month and it may no longer be able to connect to the device. So please take care not to touch those two spots. Continue in our setup with the insertion of the chip. First, you need to remove the security foil and try not to bend the chip too much. To insert the chip, the device must be turned upside down. Put the chip clamp aside and insert the chip so that it fits exactly into the notches of the device. Make sure that the chip lies flat in the device and that the three O-rings are positioned correctly and have not jumped out of their intended places. The grounding cable must not be pinched in the chip clamp, otherwise it's no longer leak-proof and liquid can cause damage. To close the chip clamp, add the springs and the washers and turn the wing nuts to the end of the threads. Your whole system is now ready for the device setup. For this, the software must be connected to the devices. This is done with the button Devices, Connect in the top bar or by clicking directly on the device icons. Now all connected devices appear blue in the instrument control. You'll be automatically redirected to the device setup, which needs to be done once per day. The first setup is the scale calibration. Please always do this as soon as the position of the scale is changed. For this, click on Start and place an empty 30 ml tube inside the scale. This is a 2-point calibration and the empty tube is the first point of it. Then click on step 1 for saving the value. For the second point, take out the tube and drop the calibration weight inside. Carefully place it back in the scale. Click on step 2 for saving the second value. Now you can have a look if your scale is really working in the correct way by clicking on its symbol in the instrument control. The next setup is the method version. Please select a version that is identical to the label of your internal standard and solution A. If the versions are swapped, the values will be displayed and saved incorrectly. Let's start the solution preparation. The solution A is the run buffer for your system. It is necessary that the ions can move in a chip and is therefore one of the most important components. If this solution is dirty or done in a wrong way, the correctness of your measurements is no longer given. Take the solution A powder, check its method version, and open the cap. Click on Prepare and put the open tube with its solution A powder inside the scale. Then click on Start and a measurement field appears. Now exactly 20 grams of distilled water must be filled. Do this either with the squeezing bottle or the more exact way with the already weighed 20-gram water tubes if they are available in your set. You simply need to spill the whole content of the water bottle inside the solution A powder and check on the scale if this is correct. Or check on the scale if you reach the 20 grams with the squeezing bottle. Now take the tube out of the scale, cap it, and then shake the tube vigorously by hand so that the powder no longer sticks to the bottom of the tube. This has the effect that the powder dissolves faster. Hang the tube on a shaker like shown and then click on the play button. There will be a countdown of 20 minutes shaking time to dissolve your powder. After the 20 minutes shaking time, the shaker stops automatically. Take the tube and check if everything is completely dissolved. If there is still powder or particles in the solution, click play again and shake the solution as long as necessary to get a clear solution. Otherwise, click on Confirm to continue the device setup. Now the device rinsing can be done with the just created solution. The main device and the inserted chip will be rinsed with it. To do this, click on Start and follow the information that appears on the right side. Fill 4 ml of solution A into the white left buffer container. Use the 5 ml syringe for this purpose. This does not necessarily have to be extremely accurate. Please be very careful not to spill any liquid outside the buffer container, as this may cause damage to the unit. Once this is done, you can close the lid and press play. A countdown starts with 1 minute rinsing time. The sound is coming from the inside of the device from the pump. What exactly happens now is this. Air flows out of the hose which is attached to the cap. This presses the liquid from the white buffer container via the chip channel to the blue buffer container. So now if you look into the open blue container, liquid must come out here during the pumping process because it is directly connected to the white container. If this is not the case, then your chip is clogged and must be thrown away. So during the rinsing process, always take this method as a quality control to check your chip. After or during the rinsing countdown, 5 ml of the same solution must now be filled into the blue container. Do this again with the help of the syringe, and again this does not have to be very exact. I would like to once again emphasize the importance of not spilling the liquid on the device. The device is now flushed. To guarantee the connection between the two containers, any air bubbles in the small opening in the containers must be eliminated. Otherwise, the necessary electrical flow will be interrupted. To do this, open both containers, take the small syringe, position the tip directly into the small hole of the container and suck up a small amount of liquid to remove any air bubbles. Fill the absorbed liquid back into the surface of the container. Now close the white container again to be ready for the measurements. Since the hose of the blue container has no function, the lid can remain open here. This is only used to avoid contaminating the buffer in a dusty environment. The test measurement can, but does not have to be made. It is used to assess the condition of both the device and the chip. The condition can be read directly from the baseline of the measurement. When you click on Test Measurement, the measurement window opens. The measurement is performed without a sample, which means that no signals or ions are detected here. In the status, you can always observe what the device is doing. When starting a measurement, the same procedure always happens. The device starts with a 30 seconds pump procedure. This flushes fresh buffer into the chip and flushes any contamination from the pre-measurement out of the channel. Then the device makes a zero adjustment, which is called offset correction. This can take different times for different chips. If the offset correction is not starting, then there is a problem with the connection between the chip and the device. Then the injection takes place. Since there is no sample in the device, this is not relevant here. After the injection, the actual measurement begins. This is the baseline. As it is displayed here, it's perfect. It should be smooth and should not have any disturbances or unwanted ups and downs. There will be examples on how a baseline should not look like and what to do in which case. As the device is very sensitive during the measurements, sometimes minor disturbances will take place. Therefore, make sure that you not touch any cables during the measurement. The device is placed horizontally on a stable place, and no other machines or devices can interfere with the measurement. The test measurement runs for 100 seconds. This is sufficient to assess the baseline. After that, the test measurement window can be closed. Since the chip is rinsed with a very viscous liquid, it must never be left in the air at its three inlets without a liquid column. Otherwise, the chip will dry out and the liquid will stick to these inlets. The chip will be broken. This is the reason why we have to fill water into the sample hole now, because there is no sample in the sample hole yet. When we do this, we prevent the inlets from drying out. Do not leave any of the three inlets without liquid for more than half an hour while there is buffer solution in the chip. For this, we need to fill in water with the pipette. The pipette works like this. Pick up a fresh tip by pressing the pipette on it. The piston of the pipette has two resistant points. To pick up liquids, push the piston to the first resistant point, immerse the tip halfway in the liquid and release the piston very slowly and continuously. To empty the liquid, place the tip against the wall of the vessel and slowly push the piston to the second resistant point. Change the tips regularly to avoid contamination. After a little pipette training, fill distilled water into the sample hole. The device could be stored now like this for hours. Perfect timing for the sample taking. Before you take the soil sample, you should know how you want to split your field, or if you want to do a mixed or a single sample. If you prefer a mixed sample, then you need to choose a pattern that represents your whole field. For single samples, you should look for smaller areas. Move to the location where you want to take a soil sample and open your MobiLab Sampler App. Hit the green plus and add a new sample. The sample ID is automatically generated and the name can be freely chosen. Now select the sampling depth and click on Submit. You must synchronize all samples that have an orange call sign with the orange circle. You'll need for sampling an earth auger, a plastic bag, a pen and a cool bag. I, for example, do a mix sample over the whole field. For this, I mix the soil of all sample spots together. Do not take samples shortly after the fertilization or rain. Write the sample ID on the plastic bag with the waterproof pen. This is especially important if you have several samples. Keep the samples in your cool box over the whole sampling time. The values can change significantly in a short period of time, especially on warm days. The samples must be prepared within 1 hour, or the next day if they are kept in the freezer. To collect plant samples, it's important that this is always done at the same time. Choose between 10 a.m. and 4 p.m. and always keep this time for further sampling. Consider if you want to sample on the sun or on the shadow side of the plant. Make sure to always collect the samples from the same side. The leaves need to have a good quality. Sample the leaves with deficiency symptoms separately. Do not sample on rainy days and avoid fertilizing directly before sample taking. Go to the spot where you want to sample your plants. Open your mobile app, click on Plants, and then hit the green plus to add a new sample. The sample ID is automatically generated, while the sample name can be freely chosen. There is also the possibility to enter the type of plant you have. Confirm this with a click on Submit and synchronize your samples that show an orange call sign with the orange circle. Two samples were automatically generated with similar ID. One sample for the young, the other for the old leaves. Basically, we are interested in the ratio of nutrients between old leaves and young, so new leaves, or the ratio of different nutrients to each other. According to the composition of your field, for sample taking, it might be necessary to divide your field in homogeneous sub-areas. The aim is to define a zone for which your leaf sample is representative. So this is the reason why we need to have two different bags, one for the young leaves and one for the old leaves. If you're just interested in the ratio of the nutrients to each other, then you just need one bag. On the spots you defined, sample the youngest leaf, which reached already full size, and the oldest, which is still whittle. The collection should be approximately the same distance to each other and span through the field. Basically, we are just interested in the petioles of the leaves. The samples must be labeled immediately and placed in a cool box. They should be prepared and measured within 3 hours. If the sample dilution has been made, the samples can also be stored in the freezer until the next day. But important is, the dilution must be already made. The number of the petioles might increase significantly if they are poor in sap, as we need a final plant sap volume of 50 microliter in order to operate the measurement device correctly. This should be a guidance on what is meant by old and young leaf. Now we have collected the samples and are ready to prepare them for the measurement. Let's start with the soil sample preparation. The sample must now be sieved and plant material and stones must be removed. After sieving, it's very important to homogenize the sample well. After clicking on Samples, Soil, you have to add the samples to the sample table. This is possible with synchronization with the mobile app, but also manually. For synchronizing, you need to log into your Fieldclimate account. Click on the green arrows now to start the synchronization. The samples from the mobile app are uploading to the software. You can find them at the end of your already existing sample list. To create samples manually, click on Add Sample and fill in the fields that are provided. The new created sample can be found at the last position of the sample table. To extract the nutrients, place an empty tube in a scale and click on Set Weight. Make sure that the scale shows 0, otherwise click Tear. Now weigh 10 grams of sieved and well-mixed sample into the tube. When you have reached 10 grams, save this value. Without removing the tube from the scale, click on Set Weight in the water column. Again, make sure that the scale shows 0, then add distilled water to the tube using the squeezing bottle. If you have activated the speaker of your computer, you will hear a sound when you reach 18 grams. Then save the value, take out the tube, cap it and write its sample ID on it. Hang the sample on a shaker and after you activate the timer, the shaker will turn on automatically. The shaking time is 20 minutes and then the field around the timer turns green. A filtration symbol appears. To filter your sample, stop the shaker in the instrument control and prepare an empty tube, a funnel and a filter paper. Remove the tube from the shaker and empty its content into the filter paper. The filtration is complete when you have reached at least 1 milliliter of filtrate. Click on the filtration symbol to continue. Click on Measure, MobiLab Device, and then you will get the information of the correct dilution for your sample for the appropriate version. In this case, you'll need 1000 microliter of prepared soil sample and then add 50 microliter of the internal standard version 3. Make sure that this dilution is done accurately, otherwise the results may differ from the original. You must not have any air bubbles in the pipette tip when you have taken up the liquid. Press the piston slowly so that the liquid from the walls of the pipette tip is also released. Always take fresh tips in order not to contaminate the solutions. Close the vial, shake it for some seconds, write the sample ID on it, and then your sample is ready. Let's do the plant sap sample preparation. After collecting young and old leaves separately, they also must be prepared separately. Cut the petioles from the leaves into small pieces. How many petioles you need depends on how rich in sap they are. Put them in a garlic press and squeeze out the sap. Then go to your samples table, click on the Plant Sap tab and add your samples either by synchronizing from your mobile application or manually. For the synchronization, you need to be logged into your Fieldclimate account. Click on the round arrows to start the synchronization. You can find them at the end of your current sample list. To do this manually, click on Add Sample and fill in the fields. click on Measure, MobiLab Device, and find here the dilution corresponding to your version. This, for example, would be version 3, so add 50 microliter of plant sap, 50 microliter of internal standard version 3, and 4000 microliter of distilled water. For this dilution, a 5 ml vial is needed. Make the dilution as precise as possible, otherwise this may lead to deviations in your results. Make sure that there are no air bubbles in a sucked up liquid in the pipette tips. Close the cap, shake it, write the sample ID on it, and then your sample is ready for the measurement. For illustration, this would be the dilution of version 4. Let's do the measurement. We start with the soil measurement. After dilution, you must set which measurement you want to make. You can choose between nitrate and ammonium, or perform both. If you perform both measurements, you must steer the sample in the sample hole between the measurements with the pipette and a fresh tip. Otherwise, the signals of the second measurement will not be sufficiently recognizable. An information appears, so that you do not forget to remove the sample from the previous measurement. To obtain accurate results, it's recommended to rinse the sample hole with distilled water or the following sample. It's recommended to do this twice. After you've confirmed, the measurement starts. To enlarge the measurement window, click in the field at the bottom right. Otherwise, you can prepare new samples in parallel. A 10-second countdown appears when the instrument is ready with pumping and offset correction. During this time, you must insert the sample into the sample hole. Therefore, have the pipette ready with the sample already loaded in a fresh tip. This is the baseline, which looks very good here. The quality of the measurement can be read directly from this line. Irregularities like hills and fluctuations indicate an unclean chip, a contact problem, or a leakage. At about 100 seconds, the first signals appear. These are called peaks. Since the internal standard generates signals, at least 2 peaks must always be visible in the measurements. Otherwise, the inlet of the sample hole is blocked. The second measurement starts immediately in sequence, if you have activated both. Between of the 2 measurements, you must steer the sample hole with the pipette and the same tip that was used before for the injection. Because during the pumping, a run buffer drop forms at the chip inlet of the sample hole. This drop isolates the sample from the chip and must be broken before the measurement. Do this also in the given time window of 10 seconds. When the measurements are finished, the peaks are automatically detected and calculated. Peaks below the detection limit are not marked. With these 4 buttons, you can view the raw and the analyzed measurements again. To use a different unit, do this at any time in the settings. You can take several measurements from one sample and find them displayed here. With a double click, you can open the single measurement. The plan-set measurement works the same way. After you confirm the dilution, you must decide what you want to measure. The first measurement includes chloride, nitrate, sulfate, and the second measurement ammonium, sodium, potassium, calcium, and magnesium. If you perform both measurements, you must steer the sample in the sample hole between the measurements with the pipette and a fresh tip. Otherwise, the signals of the second measurement will not be sufficiently recognizable. An information appears, so that you do not forget to remove the sample from the previous measurement. To obtain accurate results, it's recommended to rinse the sample hole with distilled water or the following sample. It's recommended to do this twice. After you've confirmed the measurement starts, to enlarge the measurement window, click in the field at the bottom right. Otherwise, you can prepare new samples in parallel. A 10-second countdown appears when the instrument is ready with pumping and offset correction. During this time, you must insert the sample into the sample hole. Therefore, have the pipette ready with the sample already loaded in a fresh tip. This is the baseline, which looks very good here. The quality of the measurement can be read directly from this line. Irregularities like hills and fluctuations indicate an unclean chip, a contact problem, or a leakage. At about 100 seconds, the first signals appear. These are called peaks. Since the internal standard generates signals, at least 2 peaks must always be visible in the measurements. Otherwise, the inlet of the sample hole is blocked. The second measurement starts immediately in sequence, if you have activated both. Between of the 2 measurements, you must steer the sample hole with the pipette and the same tip that was used before for the injection. Because during the pumping, a run buffer drop forms at the chip inlet of the sample hole. This drop isolates the sample from the chip and must be broken before the measurement. Do this also in the given time window of 10 seconds. When the measurements are finished, the peaks are automatically detected and calculated. Peaks below the detection limit are not marked. With these 4 buttons, you can view the raw and the analyzed measurements again. In the diagram, you can read the ratio of the important cations, potassium, calcium, and magnesium. You can find more information about this in the manual. The table is used to compare young and old leaves with each other. Download the corresponding data in the top right drop-down. You can also get more information about this in the manual. You can take several measurements from one sample and find them displayed here. With a double click, you can open the single measurement. The data import is possible in the menu under File. Here you can display existing sample lists, load individual measurements into the software, create a new sample list, or send data directly to our support. Label the data well and write a support ticket. Data will never be deleted unless you do this with a delete command. The data export is possible with Edit, Copy Samples Table to Clipboard. Open an empty Excel sheet, click into an empty field and use the key combination Ctrl and V to paste the data. Export the data with the unit you want to have. These can be selected in the settings. After your measuring data, device and the chip must be cleaned to avoid sticking. This is very important because otherwise the chip must be replaced. For this, click in the instrument control on the MobiLab symbol, Clean and Store. You are guided through the cleaning process by the software. To do this, all liquids must be removed from the device. The buffer containers are emptied using the syringes and the sample hole is emptied by using the pipette. The buffer solution does not have to be thrown away. It can be reused. Please refer directly to the label for the correct storage method. If particles are already floating around or the solution is very yellowish, use a new one. After the main part of the liquid has been removed, give the remaining liquid some time to drain from the walls of the container, and then remove it with the small syringe. Now fill distilled water into the containers using the syringes. The volume does not matter, just make sure that the liquid does not spill over the edge of the container. Close the white container and click on the next step. The pump starts and now rinses the chip with water to flush out the buffer solution. During this pumping time, remove the old sample and clean the sample hole twice with distilled water, so that the sample inlet in the chip does not become clogged for the next use. When the cleaning process is finished, remove all liquids from the device. If you need to change the chip, there is a guide in the software for this as well. Click on the MobiLab symbol in the instrument control, change chip and follow the instructions. If you are sure that the chip is broken, then go on with the chip changing guide. Otherwise, if you want to use the chip again, you have to clean the chip from buffer solution before replacing it. To replace the chip, all liquids must be emptied from the device. Never turn the device upside down if there are solutions inside. Do this with the help of the syringes and the pipette for the sample hole. Now turn the device upside down and remove the wing nuts to be able to open the chip clamp. The old chip can now be removed. Insert a new chip so that the notches fit exactly into the device. Close the chip clamp again and screw the wing nuts to the end of the thread. A new initialization must be performed with the new chip. To do this, fill 4 ml of solution A into the white buffer container and close it. Now you can do the quality check again, just as you did in the first initialization, and see if the chip is intact. During or after the rinsing, you can already fill in the 5 ml of solution A into the blue container. Perform also here again an air bubble check, like explained in the first initialization of the device, and then click on Finish. The device can be stored after cleaning of the chip. All liquids must be removed from the device. The buffer containers should remain open and the device is stored upside down so that rest liquids can run out. Store the device at room temperature and make sure it does not get wet or exposed to water vapor. The chip can remain in the device until the next use. Also disconnect the hub from the power and interrupt the connection to the battery so that it cannot be discharged. These free sealing rings must be regularly covered with a small amount of silicone grease, so that they do not become porous. Otherwise the tightness is no longer given and a leakage occurs. It's very important that the electrodes that contact the chip can be moved. If they are sticked with buffer solution and they are no longer movable, then they will cause damage to the chip. Thank you for participating in the iMETOS MobiLab training. If you have any further questions, please contact our support team. Now I wish you much success and fun with your measurements.